Assalamu alaikum dear students. In the previous class, we have done some questions regarding miscellaneous exercise of three-dimensional geometry. And there we are on question number 15 of the same exercise, and that's miscellaneous exercise. And this question is all about, we have two given planes expressed in terms of their vector equations. The equation of first plane is r vector dot I plus j plus k minus 1 is equal to 0. That's the equation of first plane. And r dot 2i plus 3j minus k plus 4 is equal to 0. That's the equation of second plane. Now we need to find the equation of plane which is passing through the line of intersection of planes first and second and is parallel to x-axis. So we have to actually find the equation of third plane which is passing through the line of intersection of planes first and second, and that is parallel to x-axis. That third plane, that required plane, is parallel to x-axis. Now first we will talk about the equation of a plane which is passing through the line of intersection of two planes. If we have two planes as a1x plus b1y plus c1z plus d1 is equal to 0 and a2x plus b2y plus c2z plus d2 is equal to 0, then the equation of a plane which is passing through the line of intersection of these two planes is, yes, a1x plus b1y plus c1z plus d1 plus lambda times a2x plus b2y plus c2z plus d2, and that's equal to 0. Means we have to find the linear combination of these two planes and take that linear combination equal to 0. That would be the equation of third plane which is passing through the line of intersection of planes first and second. But that equation is in terms of Cartesian form. So first we have to change these two equations into the Cartesian forms. The Cartesian equations of these planes are, yes, what would be the Cartesian equations of these planes? R dot r vector is actually xi plus yj plus zk, the position vector of unknown point. फिर xi plus yj plus zk का dot कर दो तो x into 1 that is x plus y into 1 that is y plus the Cartesian equations of these planes are, yes, x plus y plus z minus 1 is equal to 0. We are keeping that plane as plane number third, and यहाँ पे इन्हें फर्स्ट और सेकंड रखने की जरूरत नहीं है, यहाँ पे फर्स्ट और सेकंड रख लेते हैं. सो दिस इज आवर इक्वेशन फर्स्ट, एंड इस प्लेन की इक्वेशन क्या बनेगी? x into 2 that is 2x plus y into 3 that is 3y plus z into minus 1 that's minus z and plus 4 is equal to 0. Keep that plane as plane number second. Now the equation of any plane which is passing through the line of intersection of planes first and second must be of the form a1x plus b1y plus c1z plus d1 plus lambda times a2x plus d2y plus c2z plus d2 is equal to 0. So any plane passing through the line of intersection of planes first and second is, क्या रहेगी उस प्लेन की इक्वेशन जो लाइन ऑफ इंटरसेक्शन ऑफ प्लेन्स फर्स्ट एंड सेकंड में से पास हो रहा है? यस, x plus y plus z minus 1 plus lambda times, yes, 2x plus 3y minus z plus 4 is equal to 0. We will keep that equation as equation number third. So equation number third is actually the equation of that plane which is passing through the line of intersection of planes first and second. लेकिन यहाँ पे लैम्बडा है तो हमें इस लैम्बडा का पहले वैल्यू निकालना पड़ेगा. तो इसके लिए हम क्या करेंगे? फर्स्ट वी आर गोइंग टू सिंप्लीफाई दिस इक्वेशन. इंप्लाइज दिस इज x plus y plus z minus 1 plus lambda into 2x that is 2 lambda x plus lambda into 3y that is 3 lambda y plus lambda into 4 lambda into minus z that's minus lambda z plus lambda into 4, that is 4 lambda is equal to 0. Is that clear? So implies this can be further written as x plus 2 lambda x. x और x को कॉमन लेके आओ तो क्या बचेगा 1 plus 2 lambda into x plus y plus 3 lambda y. So result आएगा 1 plus 3 lambda into y. Yes. z minus lambda z. z और z को कॉमन लेके आओ तो बचेगा plus 1 minus lambda into z. और कांस्टेंट यहाँ पे -1 और यहाँ पे +4 लैम्डा. सो -1 plus 4 lambda is equal to 0. So this plane is of the form ax plus by plus cz plus d is equal to 0. So हम इस प्लेन के निकाल सकते हैं एटीट्यूड नंबर्स. नाउ ये प्लेन जो है ये प्लेन है पैरेलल टू एक्स एक्सिस. जब एक प्लेन होगा पैरेलल टू एक्स एक्सिस तो प्लेन का अपना नॉर्मल होगा, वो नॉर्मल होगा परपेंडिकुलर टू एक्स एक्सिस. आर यू गेटिंग मी? Since the plane is parallel to, suppose this finger is an example of x-axis, take it, it's an x-axis and this is a plane. A plane is parallel to x-axis. When a plane is parallel to x-axis, its normal must be perpendicular to x-axis. And the direction ratios of the normal are the attitude numbers of the plane. So the direction ratios of the normal, when two lines are perpendicular, the sum of products of the direction ratios must be equal to 0. This is an x-axis. And what are the direction ratios of x-axis? 1, 0, 0. What are the direction ratios of this vector? The attitude numbers of the plane. So here we are going to find the attitude numbers of the plane. The attitude numbers of this plane are. तो यहां से हम इस प्लेन के एटीट्यूड नंबर्स निकालेंगे. द एटीट्यूड नंबर्स of this plane are. हाँ स्टूडेंट्स क्या रहेंगे इस प्लेन के एटीट्यूड नंबर्स? Ordered 3 tuple of 1 plus 2 lambda. Ordered 3 tuple of 1 plus 2 lambda. Yes. 1 plus 3 lambda. 1 plus 3 lambda. And 1 minus lambda. 1 minus lambda. So these are the direction ratios of normal to plane. This are attitude numbers of this plane. Now it is given that this plane is perpendicular to, this plane is parallel to x-axis. So the normal of the plane must be perpendicular to x-axis. Now given that this plane is parallel to x-axis. Now given that this plane is parallel to x-axis, so it is normal. So it is normal must be perpendicular to x-axis. So it is normal must be perpendicular to x-axis, right? अब इस प्लेन के एटीट्यूड नंबर हैं 1 plus 2 lambda, 1 plus 3 lambda, 1 minus lambda. लेकिन एटीट्यूड नंबर क्या होंगे? डायरेक्शन रेशियोज ऑफ द नॉर्मल. और नॉर्मल एक्स एक्सिस पे परपेंडिकुलर है तो एक्स एक्सिस के डायरेक्शन रेशियोज और इस नॉर्मल के डायरेक्शन रेशियोज का सम ऑफ प्रोडक्ट 0 के बराबर होगा. सो देयरफॉर इसका पहला इसके नॉर्मल का पहला डायरेक्शन रेशियो क्या होगा? 1 plus 2 lambda. एक्स एक्सिस का पहला डायरेक्शन रेशियो क्या होगा? into 1. So 1 plus 2 lambda into 1 plus यहां पे दूसरा डायरेक्शन रेशियो 1 plus 3 lambda. एक्स एक्सिस का दूसरा डायरेक्शन रेशियो मस्ट बी इक्वल टू 0. एंड यहां पे तीसरा डायरेक्शन रेशियो दैट इज प्लस 1 माइनस लैम्डा इनटू यहां पे एक्स एक्सिस का तीसरा डायरेक्शन रेशियो 0 होगा एंड दैट्स इक्वल टू 0 बिकॉज द डायरेक्शन रेशियोज ऑफ एक्स एक्सिस आर डायरेक्शन रेशियोज ऑफ एक्स एक्सिस आर एक्स एक्सिस के डायरेक्शन रेशियो क्या होंगे? 1 0 0. The direction ratios of x-axis are 1 0 0 because the equation of x-axis is yes y is equal to 0. The equation of x-axis is y is equal to 0 in terms of two-dimensional Cartesian coordinate system, and the direction ratios of x-axis are always 1, 0, 0. The direction ratios of y-axis are 0, 1, 0, and the direction ratios of z-axis are 0, 0, 1. So implies from here we will get the value of lambda, that's 1 plus 2 lambda into 1, so 1 plus 2 lambda. This is 0, this is again 0 and is equal to 0. So implies यहाँ से मिलेगा lambda is equal to minus 1 divided by 2. So the value of lambda comes out to be minus 1 divided by 2. Substituting the value of lambda here in equation third, we will get the equation of required plane. Substituting lambda is equal to minus 1 divided by 2 in equation third. Substituting lambda is equal to minus 1 by 2 in equation third, we get the equation of required plane. क्योंकि इक्वेशन थर्ड ही है एक्चुअली इक्वेशन ऑफ रिक्वायर्ड प्लेन, लेकिन इसमें ये वैल्यू था लैम्बडा अननोन जो हमने इस मेथड से निकाला है. अब उस लैम्बडा को वापस सब्स्टिट्यूट कर देंगे तो क्या मिलेगा, x प्लस y प्लस z माइनस 1 प्लस लैम्बडा टाइम्स लैम्बडा का वैल्यू क्या है, माइनस 1 डिवाइडेड बाई 2, सो माइनस 1 बाई 2 इंटू यस 2x प्लस 3y, 2x plus 3y minus z plus 4 and that's equal to 0. Implies इसके डिवाइड डिनोमिनेटर में 1 है तो क्रॉस मल्टीपल कर दो, क्या आएगा, 2 into x that is 2x plus 2y plus 2z minus 2 minus 2x minus 3y plus z minus 4 is equal to 0. Implies this can be written as 2x minus 2x, that is 0x, leave that, 2y minus 3y, that's minus y, 2z plus z, that is plus 3z, yes, minus 2 and minus 4, that is minus 6 is equal to 0. Implies multiplying both sides by minus 1 in order to make this y as positive, तो क्या बनेगा, minus 1 से multiple कर दो तो this is y minus 3z plus 6 is equal to 0. This would be the equation of plane, required plane, which is passing through the line of intersection of planes first and second and is parallel to x-axis. So which is the required equation of plane? Which is the required equation of the plane? So the equation of that plane which is passing through the line of intersection of planes first and second and is parallel to x-axis must be y minus 3z plus 6 is equal to 0. And all about question number this 15 rather. Now we are on question number 16 of the miscellaneous exercise, and in that question number 16 we have to find the equation of a plane which is passing through a point P of 1 to minus 3 such that a perpendicular is drawn from origin to the plane where it intersects at point P such that OP is perpendicular to the plane. Means OP is perpendicular to the plane and plane passes through the point P of 1 to minus 3. We need to find the equation of that plane. Now, since the plane is passing through the point P of 1 to 3, 1 to minus 3, we can find its equation by one point form. A into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0, right? Given that a plane is passing through a point yes, कौन से पॉइंट में पास हो रहा है, P of 1 to minus 3. Since it is passing through a point, so we can find its equation in one point form. Therefore, equation of this plane in one point form is Therefore, equation of this plane in one point form is, yes, a into x minus x1 plus b into y minus y1 plus c into z minus z1, and that's equal to 0. Implies this can be written as a into x minus x1 is the x coordinate of a point through which the plane passes, that is 1, plus b into y minus y1 is the y coordinate, that is 2, plus c into z minus z1, that is z, minus z1 is minus 3, so it will become z plus 3, and that's equal to 0. We are keeping that equation as equation number first. Now that is actually the equation of required plane, but in that plane we need a, b and c. What are a, b and c? They are the attitude numbers of the plane, but the attitude numbers of a plane are the direction ratios of normal to the plane. Since OP is perpendicular to the plane, OP is normal to the plane, so we can find, if we can find the direction ratios of OP, that will become the direction ratios of normal to the plane, and that will become the attitude numbers of the plane. And yes, we can find the direction ratios of OP because O has the coordinates as well as P has the given coordinates, and the direction ratios of a line when it has been expressed in terms of its endpoints किसके बराबर होता है? Ordered three tuple of x2 minus x1, y2 minus y1, z2 minus z1, right? Now since OP is perpendicular to the plane first, therefore direction ratios of OPR, तो क्या बनेंगे OP के डायरेक्शन रेशियोज x2 minus x1, that is 1 minus 0, y2 minus y1, that is 2 minus 0, z3 minus z1, that is yes minus 3 minus 0. तो क्या बनेंगे डायरेक्शन रेशियोज? दैट्स इक्वल टू ऑर्डर्ड थ्री टपल ऑफ 1 2 minus 3. दैट इज ये डायरेक्शन रेशियोज नॉर्मल के हैं, परपेंडिकुलर के हैं, तो यही बनेंगे एटीट्यूड नंबर्स. दैट इज एटीट्यूड नंबर्स ऑफ प्लेन फर्स्ट आर. तो क्या बनेंगे प्लेन फर्स्ट के एटीट्यूड नंबर? यही ऑर्डर्ड थ्री टपल ऑफ 1 2 minus 3. So instead of A we have 1, instead of B we have 2, instead of C we have minus 3. So we can find the equation of required plane. Therefore equation of required plane is, yes, A into x minus x1, A के बदले 1 into x minus 1, plus instead of b we have 2, so b into y minus 2, plus instead of c we have minus 3, so minus 3 into z plus 3 is equal to 0. Simplify this equation, we will get the required equation, and implies, yes, 1 into x minus 1, that's x minus 1, 2 into y minus 2, that is 2y minus 4, so plus 2y minus 4, and minus 3 into z, that's minus 3z minus 9 is equal to 0. Implies this can be written as x plus 2y minus 3z minus 1 minus 4, that's minus 5, and minus 5 minus 9 is minus 14 is equal to 0, which is the equation of required plane. So the equation of this plane, which is passing through the point P of 1 2 minus 3, such that OP is normal to the plane, perpendicular to the plane, must be x plus 2y minus 3z minus 14 is equal to 0. All about question number 16 of this exercise. Now question number 17 is just like question number 15 that we have done earlier, जो हमने 16 से पहले किया, और 17 और वो 15 they are just the mirror images of each other, बिल्कुल उसी तरह है. So you can do that question number 17 by yourself. Now we are on question number 18. of that miscellaneous exercise, and in that question number 18, that's an important question as per your examination is concerned. In that question number 18, we have a plane and its equation is r dot I minus j plus k is equal to 5, and a line whose equation is r is equal to 2i minus j plus 2k plus lambda times 3i plus 4j plus 2k, means equation of a line in one point form, right? And the plane and the line are intersecting at a point. ये लाइन और ये प्लेन, मतलब आपके पास एक प्लेन है जिसकी इक्वेशन है r डॉट i माइनस j प्लस k इज इक्वल टू 5. तो ये प्लेन की इक्वेशन है, और एक लाइन है जिसकी इक्वेशन है 2i माइनस j प्लस 2k प्लस लैम्डा टाइम्स 3i प्लस 4j प्लस 2k. सपोज ये लाइन है, और जहां पे ये लाइन और ये प्लेन आपस में इंटरसेक्ट कर रहे हैं, उस पॉइंट और इस पॉइंट -1 -5 -10 के बीच में आपको डिस्टेंस चाहिए. So actually you have to calculate the distance between 2 points. One point is given and that is -1 -5 -10, and other point is the point of intersection of plane and a line. So plane है आपके पास, एक line है आपके पास, जहां पर ये आपस में intersect कर रहे हैं, उस पॉइंट और एक पॉइंट गिवन पॉइंट है जिसके कोऑर्डिनेट्स है -1 -5 -10. इन दो पॉइंट्स के बीच में आपको डिस्टेंस चाहिए. तो दो पॉइंट्स के बीच में आप डिस्टेंस इजीली निकाल सकते हो बाय अप्लाइंग डिस्टेंस फार्मूला, लेकिन तब जब आपको इस पॉइंट ऑफ इंटरसेक्शन के कोऑर्डिनेट्स मिलेंगे. तो पॉइंट ऑफ इंटरसेक्शन के कोऑर्डिनेट्स हमें कैसे मिलेंगे? वी आर सॉल्विंग द प्लेन एंड द लाइन. हम इस प्लेन और इस लाइन को आपस में सॉल्व कर देंगे. we will get the point of intersection, coordinates of point of intersection. और जब coordinates of point of intersection मिलेंगे, फिर इन दो पॉइंट्स के बीच में अप्लाई करेंगे डिस्टेंस फार्मूला, and we will get the required distance, right? The equation of given plane is क्या है गिवन प्लेन की इक्वेशन? r डॉट i माइनस j प्लस k इज इक्वल टू 5, मीन्स -5 इज इक्वल टू 0. वी विल डील विथ द कार्टेशियन इक्वेशन. सो सबसे पहले हम इसकी कार्टेशियन इक्वेशन निकालेंगे. द कार्टेशियन इक्वेशन ऑफ दिस प्लेन इज the Cartesian equation of this plane is, इस प्लेन की कार्टेशियन इक्वेशन क्या बनेगी? यस, r डॉट i माइनस j प्लस k माइनस 5 इक्वल टू 0. r वेक्टर इज एक्चुअली xi प्लस yj प्लस zk. सो x into 1 that is x plus y into -1 that's minus y plus z into 1 that is plus z minus 5 is equal to 0. We are keeping that equation as equation number first. Right? Now the equation of given line is, what is the equation of given line? Yes, given line की equation क्या है? r vector is equal to 2i minus j plus 2k plus lambda times 3i plus 4j plus 2k. But that equation is actually the vector equation of the line, and we are going to transform that vector equation into the Cartesian equation. तो वेक्टर इक्वेशन को कार्टेशियन इक्वेशन में ट्रांसफॉर्म कैसे करेंगे? डायरेक्टली यू हैव टू पुट द वैल्यू ऑफ दिस r vector. Implies r vector is the position vector of xyz, that is position vector of point having its coordinates as xyz. So r vector must be equal to xi plus yj plus zk plus and that's equal to 2i minus j plus 2k plus lambda से मल्टीपल कर दो, that is 3 lambda i plus 4 lambda j plus 2 lambda k, right? Implies this can be written as xi plus yj plus zk is then equal to 2i plus 3 lambda I, that is 2 plus 3 lambda into I. माइनस जे प्लस 4 लैम्बडा जे, जे और जे को कॉमन लेके आओ तो प्लस क्या बचेगा, -1 प्लस 4 लैम्बडा इंटू जे, राइट, एंड प्लस 2k प्लस 2 लैम्बडा के, दैट इज प्लस 2 लैम्बडा इंटू के. Is that clear? So in the LHS we have a vector and on the RHS we have again a vector, and both the vectors are expressed in terms of their components. When two vectors are expressed in terms of their components and they are equal, means their corresponding components must be equal. So equating the corresponding components, corresponding components को equate कर दो. So हमें क्या मिलेगा, we get, yes, the first component x must be equal to first component 2 plus 3 lambda. So x is equal to 2 plus 3 lambda. Y must be equal to -1 plus 4 lambda. Y must be equal to -1 plus 4 lambda. Is that clear? And z must be equal to 2 plus 2 lambda. So z is equal to 2 plus 2 lambda. Is that clear? So we have got the value of x, we have got the value of y, we have got the value of z. But what is actually x, y and z? X, y and z are actually the coordinates of any point on the line. On the line this r vector is equal to, or on the line, suppose जैसे हम यहाँ पे सेकंड ले रहे हैं, so या पहले हम इस इक्वेशन सेकंड को हम कार्टेशियन इक्वेशन में भी ट्रांसफॉर्म कर सकते हैं. सो एक्चुअली वी हैव गॉट द वैल्यू ऑफ x, वैल्यू ऑफ y, वैल्यू ऑफ z फ्रॉम द लाइन. सो व्हाट इज x, y एंड z? कोऑर्डिनेट्स ऑफ एनी पॉइंट. तो जो भी कोई पॉइंट इस लाइन पे लाई करेगा उसके कोऑर्डिनेट्स क्या होंगे, किस फॉर्म में होंगे, 2 plus 3 lambda, -1 plus 4 lambda, 2 plus 2 lambda. That is any point, on the line is of the form, किस फॉर्म में होगा, 2 plus 3 lambda. इसका x कोऑर्डिनेट होगा ऑफ द फॉर्म 2 plus 3 lambda, y कोऑर्डिनेट होगा -1 plus 4 lambda, और z कोऑर्डिनेट होगा 2 plus 2 lambda. इज दैट क्लियर? कोई भी पॉइंट जो लाइन पे होगा वो इस फॉर्म में होगा, लेकिन कोई भी पॉइंट, ये पॉइंट भी है, दैट इज द पॉइंट ऑफ इंटरसेक्शन ऑफ प्लेन एंड लाइन. सो अगर ये पॉइंट, नाउ दिस पॉइंट वुड बी पॉइंट ऑफ इंटरसेक्शन ऑफ लाइन एंड प्लेन इफ इट सेटिस्फाइज द इक्वेशन ऑफ प्लेन, बिकॉज द इक्वेशन ऑफ प्लेन is actually, yes, x minus y plus z minus 5 is equal to 0. और ये पॉइंट जो है ये लाइन और प्लेन का कॉमन पॉइंट है, क्योंकि हमने लिया है कि 2 plus 3 lambda, -1 plus 4 lambda, 2 plus 2 lambda, ये कोऑर्डिनेट्स होंगे किसी भी पॉइंट के जो इस लाइन पे लाई करेगा. अब हम कह रहे हैं कि कोई भी पॉइंट, सो ये कोई भी पॉइंट, ये पॉइंट ऑफ इंटरसेक्शन भी हो सकता है, लेकिन ये तब पॉइंट ऑफ इंटरसेक्शन हो सकता है अगर ये प्लेन की इक्वेशन को सेटिस्फाई करेगा, क्योंकि ये पॉइंट ऑफ इंटरसेक्शन है, लाइन पे भी है, प्लेन पे भी है. इज दैट क्लियर? नाउ दिस पॉइंट, would be, yes, point of intersection. Now this point would be point of intersection of plane and line if this point satisfies the equation of the plane, if it satisfies the equation of plane first. If it satisfies the equation of, or if it satisfies the plane first, अगर ये प्लेन फर्स्ट को सेटिस्फाई करेगा, सेटिस्फाई करने का मतलब x के बदले 2 plus 3 lambda, instead of 5 -1 plus 4 lambda, and instead of z we have 2 plus 2 lambda. So therefore equation of plane is actually x minus y plus z minus 5 equal to 0. Instead of x we have 2 plus 3 lambda, minus, instead of y we have -1 plus 4 lambda, and plus z, instead of z we have 2 plus 2 lambda, right? So instead of z we have 2 plus 2 lambda and minus 5 is equal to 0. तो ये रिक्वायर्ड पॉइंट ऑफ इंटरसेक्शन, ये पॉइंट ऑफ इंटरसेक्शन ऑफ प्लेन एंड लाइन जो है इसके कोऑर्डिनेट्स एक्चुअली किस फॉर्म में होंगे? 2 plus 3 lambda, yes, -1 plus 4 lambda and z कोऑर्डिनेट क्या होगा? 2 plus 2 lambda, right? So implies from here we will get the value of lambda. So implies this can be written as 2 plus first we are going to simplify this, that is 2 plus 3 lambda minus into minus 1, that is plus 1, minus 4 lambda plus 2 lambda minus 5 is equal to 0. Implies 3 lambda plus 2 lambda, that is 5 lambda minus 4 lambda, that's lambda, right? Now 2 plus 1, that is 3, plus 2, that is 5 minus 5 is 0. So lambda plus 0 is equal to 0, means lambda must be equal to 0. Put the value of lambda here, you can find the coordinates of point of intersection. Therefore coordinates of point of intersection, therefore coordinates of point of intersection of plane and line are क्या होंगे coordinates? 2 plus 3 lambda, 2 plus 3 into lambda का वैल्यू 0, yes, minus 1 plus 4 lambda, that is again 0, 2 plus 2 lambda, that is 2 plus 2 into 0, that is the value of lambda. तो क्या मिलेंगे रिक्वायर्ड पॉइंट के कोऑर्डिनेट्स? 2 plus 0, that is 2, minus 1 plus 0, that's minus 1, and 2 plus 0, that is 2. So the point of intersection of line and plane, this point has the coordinates, yes, 2 minus 1, 2 minus 1, 2. Since we have the coordinates of both the points, now we can find the required distance. Therefore required distance must be equal to, therefore required distance must be equal to, since suppose this is point A, this is point B, we are going to find the distance between 2 points A and B. The distance between 2 points must be equal to square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. So required distance must be equal to square root of, yes, 2 minus minus 1, that is 2 plus 1 square, minus 1 minus minus 5, that is plus minus 1 plus 5 square. Is that clear? Because x2 minus x1, that is 2 minus minus 1, that is 2 plus 1 square, y2 minus y1, that is minus 1 minus minus 5, that is minus 1 plus 5 square, and plus z2 minus z1, that is 2 minus minus 10, that is 2 plus 10 square. That must be equal to square root of 2 plus 1, 3 square is 9, minus 1 plus 5, that is plus 4 square is 16, and plus 10 plus 2, that is 12, and 12 square is 144. So this will come out to be square root of 144, 9 plus 16 is 25, 144 plus 25 is 169, and square root of 169 must be equal to 13 units. So the distance between the points minus 1, minus 5, minus 10 and the point of intersection of plane and line must be 13 units. The required distance between the points minus 1, minus 5, minus 10 and the point of intersection of given line and given plane. So that was all about the question.